Hello dear student, good morning. Now we have to start with that the 14th chapter, that is basic principles of that organic chemistry. Now see that there are so much types of that chemistry, but we are interested here in that the organic chemistry will be there. So see that the chemistry in which that the study of carbon and carbon compounds, it is simply called as an organic type of this chemistry. Now said, what is the idea of this carbon and carbon compounds are there? So nearly there is 27 million organic compounds which are exist in this nature. So said very broad study about that the carbons are there, and carbon has its valencies 4. So it's a ability it will be forms that the bonding with different types of that elements. But it's a carbon is the orientation. So study of that carbon orientation and their compounds is simply called as an organic type of this chemistry. Basically, we know up to that your 10 standards are there. So alkanes, alkenes, alkynes, some aromatic compounds. These are the basic known names are to be there. Now so that this organic chemistry containing that organic compounds are there. So carbon containing all compounds are simply called as that it's a organic compounds are there. Now see that these organic compounds can be represented by that various types of these formulas are there. So first one I can draw here, that is structural formula is there. So structural formula, it represents what is the exact structure of that compound. So it is called as that structural formula. Suppose we want to show that the molecular formula of that ethane. So ethane having this molecular formula is C2H6. This 2 carbon and 6 hydrogens are attached here. So it's a represented in the structure form. It can be write like this. So this carbon-carbon bonding is there, which is singly bonded, and say that this hydrogen also singly bonded in such way. We say that this C2H6 is a molecular formula, and say that it is how exact arrangement of this bond that can be shown by the structural formula is there. So this is the structural formation will be there. So carbon-carbon 1 bond exists and carbon-hydrogen 6 bonds are to be exist, and such representation is called as that it's a structural formula is there. Now similarly, that second, it is at a condensed formula. Now so that this molecular formula is also divided into that simple forms. Condensed means what? Compact. So that it's a distribution of these two carbons containing these hydrogens. So it's a condensed form is like this. So this condensed formula I can write like that. So it is represented by not the its a distribution or that actual bonding, but it will be combined form will be there. So this CH3 I can represent that CH3, again this single bond and then CH3. So this CH3 it is simply called as that condensed formula is there. Or in also that condensed formula, suppose that CH3, this CH2, this CH2, this CH2 and then CH3. Then what happens here? So it will be happening that a simple group, that is CH2, which is frequently repeat here. So those groups which are repeated, which are to be represented in the simple bracket. So condensed formula, it should be again represented like this. That is CH3, this CH2 thrice times of that CH3. Or it may be also represented like that. That is CH3, then this CH2, then 3 and then CH3. Means that this bond is not necessary to show into it. So this is a simple formula of that the condensed form is there. Now this third formula, according to it, it's a bond line formula is there. So this third bond line formula, it is represented. Now so that this CH3, that CH3, it will be represented in the bond line form. It is like this. So this is a 2 corners are there. So this corner actually it is it containing that 2 carbons. So these are the terminal carbons. It can be represented into it. So this is CH3. Means that bond line containing that all these compounds and their bonding can be shown by that single lines are there. So this is called as a bond line formula. Suppose I can represent this bond in such a way will be there. Suppose. Then what happens here? So it's the actual meaning. It is like that. This is a CH3. Now so that it will be combined. Then it will be get that CH2. Then again it will be getting that this is CH. And this double bond will be there. So that's why it is a double bond is like this. That is CH2. So this is showing by that simple lines are there. So it is called as a bond line formula. Now fourth one is that the wedge type of this formula. So in case of that wedge line, that plane of paper, below the paper and upper paper. This to be that the above the paper. This is an important concept into it. Suppose any molecule will be represented like that. So suppose I can say this Ca, then this Cb, and say that this can be represented by such a way. So this is a way will be there, and say that suppose this is a C molecule, the C atom will be there, and this is a D atom will be there. So say that these two lines, that rough lines, it is at the on the paper. It can be shown that on the paper. This line can shows the below the paper, and this is that above the paper. Means that it's a representation. Will be that on the paper, above the paper, and below the paper. Suppose molecule can be represented in such at which that carbon is to be merged to that centrally attached into it, and this representation shows that the wedge type of this formula is there. Now next one, it is related to that. That's a Fisher formula. So Fisher formula, it will be shown by that the simple lines are there. So for example, suppose glucose is there, and say that this glucose can be represented in such way that its actual formula is like this. That is it's a molecular formula is C6H12O6, but it is represented according to this way Fisher's formula. It is like that. So that this carbon, which is like this, so those functional group will be there. So it can be shows into this. That is C double bond OH. This is a functional group, and so that their bonding is like that. This H OH group is there. Again this OH and this H. So this H, again this OH, again this H and this OH. So this first carbon, second carbon, third, fourth, fifth, and this in the sixth carbon. So it will be getting that it is represented like that. So these four groups are there, and this is a CH2OH. This first, second, third, fourth, fifth, and sixth. Now see that this line can be represented. It's a bond. So this is a formation of that Fisher is there. Means what happens here? This centrally it is represented. This is a carbon, this carbon, this carbon, like this. And so that terminal and that it's above last and first carbon, which is showing by that the functional group. It is actually represented by that its actual form. But middle all these things which are to be represented by these horizontal lines. This is called as that Fisher's formula is there. Now similarly, that Newman formula is also there, or it is also called as a Newman projection formula is there. So in this Newman projection formula, it can be represented in that the simple circle forms are there. So suppose I can say that ethane is there, ethane having this formula C2H6, and say that this ethane can be represented in such a way. So I can say that this CH3 means that this bonding is represented like that. So this is a simple structural formula. So its a bonding is like that. It can be shown in such a way. So say that this is a hydrogen, this is a hydrogen, this is a hydrogen. Now see that it is a above the plane, and see that this backward hydrogens, which is like that. This hydrogen like that. We say this above the plane and back the plane. It can be represented in such a way. So it is called as that. It's a Newman projection formula is there. Similarly, that seventh formula, that is the Sawhorse formula is there. Sawhorse formula, it is represented. One side is upper side, one side is below side. Suppose I can say that suppose ethane is there. So it can be represented in such a way. So say that it is like this. It is again below the paper, above the paper. So say that this is the idea behind it. So this is a ethane molecule in which that this is the first carbon, this is the second carbon. So that is C1 and C2. And these hydrogens, again that it is above the plane, it is below the plane. This is sidewise, then it's the opposite of that hydrogen, which is at the below of it. It is the upper side, then it is the below side. So these are the 7 ways in which that the organic molecule can be shown into it. Our next chapters are again in the hydrocarbons. Next year also that various chapters which is belonging to this organic chemistry. So all types of these formulas are to be implemented and very useful to determine into it. So see all this in that textbook, and any problem then you can personally to state myself. Okay, thank you.